Alright, this is our last topic in our acid-base unit, concept G. We're going to be focusing on something called hydrolysis, which actually takes a look at the salt produced in neutralization reactions. So a common neutralization reaction that we've done is hydrochloric acid and sodium hydroxide. And we know the salt produced is sodium chloride. Now if we tested the pH of that salt, its value would be 7. But many of the salts that we actually produce in neutralization reactions aren't neutral when they go and redissolve back into water. So something called ammonium chloride actually produces an acidic salt, which then dissociates and produces that acidic solution. We have potassium carbonate that produces a basic solution and is considered a basic salt. So why is this occurring? Well, not all acids and bases are strong. A lot of the reactions we've been doing so far involve both a strong acid and strong base reacting, but acids and bases can be strong or weak. You have to know that acids that are in the top 5 on table L are considered strong, meaning that they ionize completely. And then the bases that are considered extremely strong are any of our group 1 hydroxides, so lithium hydroxide, sodium hydroxide, and so on. These dissociate completely. So you have to memorize these two facts in order to determine what we're going to do today. So I just have that reminder up at the top. So NaCl we know was produced by HCl and NaOH. These are both strong, so our salt solution is neutral. However, the ammonium chloride being produced from HCl and NH3, we have a strong acid but a weak base. So our salt is acidic. And again, meaning that that salt can go and redissolve back into water, producing an acidic solution. And then finally, the potassium carbonate is formed from a weak acid and a strong base, so the salt is considered basic. So the salt hydrolyzes into water, we say, and the thing is that this is redissolving back into water and affecting the pH. So what can we expect to happen? Well, as we said, a strong acid and a strong base are going to produce a neutral salt and thus a neutral solution. However, when we look at the exact opposite of having both a weak acid and a weak base, if both of them are weak, we simply cannot make a prediction due to the wide range of Ka and Kb values. So in that case, we would have to say that we can't predict. Strong acid, weak base is going to produce an acidic solution, and then a weak acid and a strong base is going to produce a basic solution. So again, being able to tell what are their strongest acids and bases will allow us to predict the salt. So earlier in the unit, and you might want to go back and look at those notes or go back to the video, is we talked about neutralization reactions. And I had you guys work backwards in class to determine if I gave you the salt, what the acid and base that formed it, what their formulas were. And that's what we're going to kind of bring back up today and add in the step of, is it a strong or weak acid or base? So magnesium chloride got formed from HCl. Remember, the negative ion is going to form with the positive proton in the acid. And then magnesium hydroxide, where remember the positive ion of the salt is going to reform with the negative hydroxide ion. So keeping in mind the rules that we talked about, top 5 on table L for acids, and then group 1 hydroxides are the strongest for bases. In this case, we have a strong acid, weak base, so you should be able to predict that we're going to have an acidic salt. All right, going ahead with lithium fluoride, you had HF and LiOH. In this case, we have a weak acid, strong base, so that's going to produce a basic salt. Here we have HI and RBOH. We have 2 strong acids and bases, so that means that we're going to produce a neutral salt. So take a second and see if you can fill out the rest of this chart, especially practicing writing the formulas of acids and bases, and then using the couple of facts that we talked about to determine which ones are strong. So hopefully you figured out that for this next one, aluminum nitrate, it comes from HNO3 and AlOH3, so nitric acid and aluminum hydroxide. We have strong acid, weak base, so that means that our pH is going to represent an acidic salt. Moving ahead with calcium bromide, HBr, and calcium hydroxide, strong acid again, weak base, so we have again an acidic solution. And then with our nitric acid and lithium hydroxide, we have a strong acid and a strong base, so we're going to produce a neutral salt. And then finally, in the last one, we see that we have a weak acid and a weak base, so we're not able to predict. Now, some chemistry classes will take this concept a step further, analyzing data, doing various calculations. However, for you guys right now, you just have to be able to identify the strengths of acids and bases of that formed the salt that we're looking at, and then determine the relative pH values. All right, so again, there's no, as you know, no quizzes or summaries for this unit, so you can go ahead and just review your notes and come to class prepared.